Hi, my name is Juan. Now I'm going to use the definition of the limit to prove that the limit when x goes to 3 of the absolute value of x minus 3 is equal to 0. Now, the definition states that as long as the limit exists, we, for all given epsilon greater than 0, there exists an delta greater than 0 for all real numbers. So we say that the absolute value of the function minus the limit is going to be positive and it's smaller than epsilon, as long the absolute value of x minus the x value that we're evaluating is positive and smaller than delta. Now, if we use those definitions over there, using the information that we have from the limit, we can say that the absolute value of x minus 3 minus the limit, in this case is 0, is less than epsilon. Then the absolute value of x minus the value that we are evaluating, which is 3, is going to be positive and smaller than delta. Now, if we look in this side first, we can see that the absolute value of x minus 3 minus 0 is less than epsilon. We can say that this, starting from here, is the same thing as the absolute value of x minus 3 is less than epsilon. Now the absolute value of an absolute value is an absolute value, so we can say that this is the absolute value of x minus 3 and is less than epsilon. So now if we compare for epsilon with this definition here for delta, we can let delta be equals to epsilon. Now, in order for all this to be true, we need to prove that actually my delta is a minimum value between epsilon and a value here. That value, we want epsilon or delta to be smaller, so we don't want it to be greater than 1. So we can put here the 1. That way we're gonna bounded the delta value in a small number, right? Now we need to prove that this assumption is actually make that estimate true, that the value given for epsilon is going to give us the smaller delta that we have. So from there, we can start from this point. We're going to say that the absolute value of x minus 3 is less than delta, right? And then, so we know that delta is equal to epsilon, so we actually can say that this is less than epsilon. Now we can open this absolute value as negative alpha less than x minus 3 less than epsilon, right? So what we did here is just splitting the absolute value in both ways, the positive and negative. Now, the idea of all this work is try to get back to where we start. If we get to this part without having any problem, we just prove that our delta will be equals to our epsilon. So now what we can do starting from here is we know that we want this piece or epsilons or deltas greater than 0. So we can say that the absolute value of x minus 3 is between negative epsilon and epsilon, right? You may ask, but I have a negative number here. But still, I'm not saying that my absolute value is negative. I just put it that bound there. But this is still saying that this is true, right? Because I don't know where is this part. So I cannot say so far that this is negative. So this is still implying. So we have this. So now comparing this with this, I have a 0 there. So what I want to do is add that 0 both sides, here, here, and on the middle. So that's telling me that 0 minus epsilon is between x minus 3. This is not changing because I added the 0, but it will change if I have something different than 0. Now, we have this. Now, by assuming no, we know that x minus 3 is greater than 0. So we can say that this, we can say, it's better, we can say that 0 minus epsilon is less than the absolute value of x minus 3 less than epsilon plus 0. Now, you may say, okay, where that absolute value comes from. So we know that the x minus 3, the absolute value of x minus 3 is greater than 0. That's the idea from the beginning. We want that to be true, we can say here. So because of that, we can assume that the absolute value is between these two values. Now you may say, okay, but this value here is negative. But again, I'm not saying that my absolute value is negative, I'm just putting that as a boundary. Right? I'm just saying that my absolute value is between two numbers. So I'm not changing much of what we were saying before. Now, we want to make this as close possible to where we start. So now what I'm going to do is going to subtract the 0 from everywhere. Right? So you can see that here we can say that this is going to be epsilon less than the absolute value of x minus 3 less than 0, minus 0, less than epsilon. Right? And if we see here, it's very similar to where we start. So if we come from this point to this point, by splitting the absolute value, we can come back from this point to this point. So using this, we can say that this is the absolute value of x minus 3 minus 0 less than epsilon. So now, working all these steps through, we come back to our original assumption, and we just prove that this assumption is true. So I can say that for a given epsilon, my delta will be equals to that epsilon.